Hello everyone. Welcome to this training session on statistical data analysis using SPSS. My name is Vamsidhar, and as a part of this session I am going to take you through the t-tests. T-tests are primarily used to test for the means. See, we have used a lot of procedures to compute the means or the averages of the various variables. Now, moving on to the world of conclusions, right? The moment I do some calculation, I have to make some kind of an inference based on the calculations. So every calculation that we are doing, we have a statistical inference to be made, which we have discussed using our understanding of hypothesis testings. Hypothesis testing is a mechanism which tries to create an inference from the calculations. Now, any inference about the mean of a population, any inference about a mean of a population, we can do the testing using the t-test. T is a statistical distribution just like a normal distribution. So if at all our business requirement is to do some kind of a testing with respect to the averages of a population, then we can use the t-test. So some of the scenarios could be test whether the average height of the males is greater than the average height of the females, or test whether the average height of an Indian male is equal to some 65 inches or is significantly greater than 65 inches, or probably it could even go to an extent saying check whether the average weights of people have decreased before and after the treatment or after the medication. So wherever we have to make some kind of conclusion regarding the averages of the populations, we can resort to the usage of these t-tests. So we'll use a couple of examples in our case study, which will make things clearer for you. So here I would like to make an assumption, or I would, whenever we are doing some kind of t-test, there is an assumption saying that the data is normally distributed. Whatever is the testing we are doing, that is the reason we have stressed a lot in our earlier sessions on the normality in the data. The reason being, if at all I have to do some kind of a conclusion about the mean or the variance or any of the typical calculations, it is assumed that the data is more or less normally distributed. So that is where I want my data to be normally distributed, and as we have already discussed earlier, some of the tools for checking out for the normality is I can use the exploratory data analysis of SPSS to check for the normality, or I can even quickly look at the skewness and kurtosis levels and finally say whether the data is normal, or I could very well use the box plot to identify if there are any kind of outliers present in the data, and based on that test out for the normality of the data. But once I have assumed that, or once I have understood that the data is normal, I can think of performing some kind of comparisons of the averages. So as far as this session is concerned, I'll take up three different t-tests, one being the one sample t-test, Then I have a paid sample t-test, and in the next slide I will be showcasing the independent sample t-test. So these are the three kinds of t-tests which we would be discussing here for doing three kinds of business tests. One is whenever I want to test, whenever I want to test whether a sample mean is equal to a hypothesized value, a constant, comparing the mean with a constant, comparing the mean of a data with some constant, I'll use one sample t-test. If I am comparing a pre and post kind of a scenario, like before the treatment versus after the treatment, compare the weights, especially when I am going with one single subject, I mean for two different variables, and I am capturing the data between the two different variables before and after kind of a scenario, or a kind of a matching pair, male and his spouse, not any other female. So wherever we have a kind of a matching pair data to be analyzed, or pre-post kind of data to be analyzed, then we will resort to a paired sample t-test. We'll again come back to that. First, let's focus on one sample wherein my intention is comparing the mean of a data with a constant. So whenever the sample mean must be compared to a known test value, I am going ahead with the usage of one sample t-test. So from our case, I am looking at two questions from this case study, saying check the hypothesis whether the average height of the population is 67 inches. So I am comparing it with a known constant value. So for that, I'm going ahead with the t-test, and that too one sample, because I'm taking the whole population and I'm comparing it with a constant value. I'm comparing it with a constant value. That's where I'm using the one sample t-test. Alright, let's go to our data, and I'll make a simple conclusion, or I'll make a simple analysis saying analyze, compare means, wherein I'll go with one sample t-test, and in this I can look out for the value. I'm assuming here that the height is normal. We have tested earlier also, but one thing we have to make sure before we do this entire work is ensure that the heights data is more or less normal. So here I am by default assuming that the heights data is normal, and based on that assumption I am going ahead with a test value here. The test value I am putting 67. Check whether the height is equal to 67, and probably you can set a confidence level. I'll keep the default confidence level itself as 95%. We'll discuss about it, and that's it. Probably when I do this, what I am getting is a very simple outcome, saying okay, there are 400 records for which I am analyzing the height. The mean from the sample, the mean from the sample has come out as 66.18. I am comparing it with 67. Is there any statistically significant difference between the statement which I have made, which is 67, and what has been calculated, which is 66.18? I want to know whether this difference is statistically significant, or there is not much of a statistically significant difference between the two. That is what is my analysis all about. And before I do that, I am even computing the standard deviation, which is working out to around 7.22 in this case, and the standard error is nothing but mean sorry, standard deviation sigma by root n, 7.2 divided by square root of 400. That is what is the standard error of the mean. Standard error of the mean is something which is useful for determining the 95% or whatever is the confidence interval for the estimate. We'll come to that. So here we are looking at the mean, the standard deviation and the standard error before we get into the conclusion part of it. So this is the one sample t-test. One sample t-test table is this. So what you are seeing is a t-value. The t-value is nothing but the mean difference, whatever is there. Mean difference, how did I get? 66.18 minus whatever is my assumed difference, whatever assumed height. I have assumed or I have hypothesized a height of 67. So the mean difference, which is 66.18 minus 67, which is working out to minus 0.81. The mean difference divided by the standard error of the sample mean divided by 0.36 minus 0.81 divided by 0.36. That is what comes out as the t-value, and the degrees of freedom always is 1 less than the total sample size. Using these two things, I look out for a t distribution table, and for us as the interpreters of the data, I don't need to be so much technical. For me, what matters is the significance level itself, right? As an interpreter of the data, I only look out for one single field, the significance level. My conclusion comes only from that significance level. I'll check whether it is less than 0.05. If the significance level is less than 0.05, I'll say that the hypothesis can be rejected. The null hypothesis